All right, we got to file system. Now, file system is an interesting one because we do not have a consistent way to work with file system across these different platforms. So if you have built desktop or web applications with C#, you're probably familiar with this system.io namespace. Here we have classes like file, file info, directory, directory info, environment, and so on. Now on Android and iOS, we can use these classes to work with file system. But starting from Windows 8.1, Microsoft designed a new model to work with file system. So we have a different namespace with different classes, and all the methods are different in terms of naming, in terms of their signature, and all of them are asynchronous. So we have different models to work with file system across these platforms. Now you might ask, okay Mosh, with these differences, how are we going to use file system in our applications? The solution to that is interfaces. So in our portable class library, we're going to declare an interface like iFileSystem. So this is the contract to work with file system. Inside this interface, we'll declare methods that work with files and directories. For example, here I've declared an interface with two methods: getFiles, which returns all the files in the given path, and writeText, which writes a text file. Now we could have many other methods here, and that really depends on the application we're building. Once we have this interface, we can provide different implementations for different platforms. So for Android and iOS, we'll provide an implementation that uses system.io namespace. And for Windows, we'll provide a different implementation that uses the new model. As you can see from this picture, the implementation for Android and iOS is exactly the same. So we can literally copy-paste the same implementation in these different projects. So this is the big picture. But there is a problem here. Chances are we need to work with file system in different applications. So it's going to be tedious to declare this interface and provide its implementations over and over and over. But the good thing is we don't have to do this. There is a NuGet package called PCL Storage, and we're going to look at that in the next lecture. So PCL Storage provides an interface that has all the methods to work with file system. And it also provides implementations for various platforms. I explained this architecture so you have a better understanding of how everything works under the hood. So you know PCL Storage is no magic. Now, before we move on to PCL Storage, I want to show you some code. But remember, do not type or memorize anything. I just want you to look at the code to get a feel about how everything fits together. All right, here in Visual Studio, in Solution Explorer, let's expand this portable class library. So here's our interface, iFileSystem. And currently I have declared only one method. As you can see, this is an asynchronous method because it returns task and it has the suffix async. Here we get a file name and some text to write in that file. Now let's take a look at the implementation of this interface in iOS. So here's the iOS project and file system class. So you can see this class implements iFileSystem interface. In writeText async method, first we use the environment class to get the folder for this application. So as the argument to this method, we're supplying my documents, which is a member of special folder enumeration. So every application has a folder where it can store its files. And the purpose of the first line is to get the path to this folder. Next, we combine the path of the folder with the file name. And finally, we use the file class to write some text to this file. So pretty basic. Now let's look at the implementation in Windows project. So here's the Windows 8.1. Again, we have another file system class. But here we are not using the file class. So if I type system.io.file, look, we don't have this class in system.io namespace. So this namespace on Windows is a bit different from what we have in Android and Windows projects. Here instead we use windows.storage. And in the implementation of writeText async method, look, we don't have the environment class. So to get the application's current folder, we use application data.current.local folder. And this returns a storage folder class which is defined in windows.storage namespace. So it's a different model. Now you don't have to memorize any of this stuff. All I want you to pay attention here is that the implementation here is different from iOS and Android. Now let's say in our portable class library, we want to work with file system. Here in the PCL, I'm going to go in the code behind for main page. So here we need an implementation of iFileSystem for the current platform. How do we get that? We have a class in Xamarin called dependency service. And this class has a static method get, which is generic. So here we specify iFileSystem. And this dependency service will return an implementation of iFileSystem based on the current platform where the application is running. So we get this object file system. And now we can access its methods in a cross-platform way. So filesystem.writeTextAsync. So from the perspective of PCL or portable class library, our code is cross-platform. But the implementation of iFileSystem is different for each platform. Now, one last thing. In order for the dependency service to be able to find an implementation of iFileSystem, we need to register our implementations. So let's go back to one of these implementations. For example, the one in iOS. Look at this line here. We have this attribute assembly:dependency. Again, this is part of Xamarin. And this dependency attribute takes an argument, which is a type. So here we are passing type of helloworld.ios.filesystem. So this is the fully qualified name of this file system class in iOS project. With this attribute, we register this file system implementation with our dependency service. So when this assembly, the iOS assembly, is compiled, this attribute adds metadata to this assembly. Now back in our main page, at runtime, when we call dependency service.get iFileSystem, this dependency service looks at the assemblies that are available in the current folder and then scans their metadata. So if we register our type using the dependency attribute, it will be visible to dependency service. And then it will create an instance of this class and return it. So this is how dependency service works. All right, next we're going to look at PCL storage.